July 22, 1941, a date that would quietly reshape armored warfare. On that day, the U.S. Army standardized the SCR-508 series radio set for medium tanks. In cramped turret bustle and muddy engine bays, Sherman tanks were no longer just steel and gun. They became nodes in a network, speaking by voice over invisible waves. While German tanks still relied heavily on AM sets and rigid hierarchies of command, American crews were beginning to benefit from something more fluid: real-time coordination, clear voice communication, and an edge the enemy could not immediately hear. In the years before America entered full war, the U.S. Signal Corps invested heavily in mobile communications. Older radios like SCR-245 and SCR-293, though serviceable, suffered from loud engine noise, static, and unclear voice signals, especially when tanks moved or during electrical interference. Combined with signal flags, runners, and visual cues, the system was effective, but far from optimal. By July 22, 1941, SCR-508, along with variants SCR-528, SCR-538, was standardized. These radio systems replaced or supplemented the older ones in U.S. armored units. The doctrine shifted. Armored units would move as voice nets, relying on radio rather than just commanders shouting or using visual signals. Sherman's medium tanks of the U.S. Armored Forces were built to carry these radios. Many command tanks got full SCR-508 sets, others with slightly reduced variants. These are the confirmed, verifiable technical details for the SCR-508 family radio systems. Transmitter: BC604, crystal-controlled, FM voice or CW Morse. It has 10 preset crystal channels. Frequency range: 20.0 to 27.9 MHz. Power output: roughly 25 to 30 watts, depending on variant and supply. Receivers: the SCR-508 set typically included 2 BC603 receivers, allowing the crew to monitor more than one channel. Power supply: dynamotors able to work with 12-volt or 24-volt system input for transmitter and receivers. Typical range: around 7 miles while moving under favorable conditions. Somewhat more when stationary and with clear line of sight. Weight: approx 181 pounds for the full SCR-508 set transmitter. 2 receivers, mounting hardware. These characteristics gave Sherman strong, clear voice net capability. Ability to send commands, receive reports, maintain situational awareness, even whilst moving in difficult terrain or engine noise. While Americans pushed forward with FM and crystal control, German armored radio systems had both strength and limitations. Here's what the sources confirm. Fu G5 was the standard tank M transceiver for many German tanks including Panthers ZC. It operated in the 27 to 33.3 MHz range. Transmitter power: 10 watts in many documented versions. Channel spacing/channels: the Fu G5 provided multiple channels, 125 channels, spaced 50 kHz in some documentation. Axis militaria: range under M voice. When used for voice under movement or with engine/electrical interference, the range drops significantly, on the order of 2 to 3 kilometers typically. In Morse/CW or under ideal conditions, perhaps more 3-4 kilometers. Receivers versus transceivers: German doctrine placed important tanks platoon or company command with full transceiver capability. Others might have just receivers. If command tanks were knocked out, inability of subordinate tanks to transmit back could degrade coordination significantly. Reliable sources support that variation. Here's why the SCR-508's FM/crystal-controlled voice capability was more effective. Static and interference suppression: FM design naturally rejects amplitude fluctuations, noise, engine spark interference. AM is more vulnerable, especially in noisy, moving conditions. The BC604 in SCR-508 gave clear voice communication even when tanks were in motion or working under smoke and vibration. From tech analysis sources: Radio Nerds / the Sherman Tank Site. Crystal-controlled channels. In SCR-508, presets meant that channel switching was fast and frequency drift minimal. German AM sets relied more on tuning and sometimes were less stable in frequency, especially under temperature changes or vibration. Dual receivers: SCR-508 2BC-603s meant crews could listen on two channels or monitor traffic while receiving orders. That improved situational awareness. Moving range versus stationary range. While U.S. Shermans could often get several miles of reliable comms while moving, German tanks with Fuji-5 could see voices drop off with motion, or require stationary position to maintain clearer link. U.S. Armor Doctrine Post 1941 emphasized radio communications, platoon and company voice nets, intercommunication between tanks, and coordination with infantry and artillery. Crews were trained to use the SCR sets, crystal changes, using intercom within vehicle, and external voice net links. Doctrine manuals, TM11 to 600 for SCR-508, reported in Sherman Tank Technical Histories. Command versus gun tanks. Many Shermans in a troop had full SCR-508 sets if they were leader tanks. Gun tanks sometimes had reduced capabilities or fewer crystal sets. But even non-command Shermans often had at least one receiver to hear orders and warnings. German practice stressed command tanks transmitting orders, sub-tanks acting. But when command radios were destroyed or when communications links were jammed or interfered, poor coordination followed. Runners or signal flags were backups but slower and dangerous under fire. Field condition stressed equipment. Vibration, dust, cold or heat, antenna damage, electrical system noise. The FM sets held up relatively well, but they were bulky, required dynamotors, which themselves needed maintenance. SCR-508 sets required spare crystals, spare parts, careful mounting of whip antennas. In many tanks, damage to antenna or wiring could degrade range or clarity. German AM radios similarly suffered under certain conditions: engine interference, static, broken receivers or transmitters, and sometimes use of low-quality antennas. By early 1942 to 43, the technological foundation for superior communication was deeply in place for U.S. Sherman units. But doctrine, training, supply lines, and battlefield conditions still had to align for this advantage to show itself in clear, measurable ways. Shermans with fully functioning SCR-508 units, crews trained to use them, dependable maintenance, these would be the units most likely to exploit the advantage. When U.S. Shermans began confronting German tanks in North Africa and later in Italy and Northern Europe, the contrast would emerge. German tanks had excellent armor or powerful guns, but in many engagements they could not respond quickly, could not coordinate as fluidly, or were slowed by poor radio clarity. The sky over the battlefield had begun to whisper of something new. Clear voice, moving networks, channels switching, orders flowing. Not visible like armor or cannon, but nevertheless profoundly powerful. After laying the foundations with SCR-508 specs and doctrine, the desert proves to be the first unforgiving test. Sand, heat, dust, and the roar of panzers under an unforgiving sun. It is here, in Tunisia, especially at Kasserine Pass, that the U.S. radio edge begins to show itself in combat, not just in lab tests or theoretical doctrine, but in life and death coordination under fire. November 1942. Operation Torch lands Allied troops in Morocco and Algeria. Sherman tanks accompany the U.S. Army's armored divisions pushing east. The SCR-508 sets are being installed in many of the Sherman medium tanks prior to arrival. Crews trained in FM voice nets, crystal channel drills and supply depots, whip antennas packed and tested. But the desert is cruel. Heat warps metal, sand clogs circuits, electrical systems buzz with interference, radio antennas break, cables fray. Shermans that had flawless communication during training find voice dropouts in sandstorms, engine roar masking commands. Despite that, FM clarity, crystal preset channels, and dual receiver setups still give U.S. crews a relative advantage over many German units whose AM sets struggle with static and interference in movement. February 18-24, 1943. The Battle of Kasserine Pass becomes a harsh lesson in the limits of U.S. doctrine and leadership. Logistics, inexperienced troops, supply issues, command missteps all laid bare the weaknesses. Yet even amid defeat, there are moments where coordination, when it works, gives U.S. units a fighting chance, while direct, documented accounts of FM radio superiority in Kasserine are less abundant. After-action reports and veteran memoirs suggest that units equipped with functioning SCR-508 voice nets had better situational awareness, receiving orders more reliably, adjusting to German flank maneuvers more quickly. A U.S. tank crew, for example, could warn of incoming reconnaissance or flank threats, even while moving across broken ground, because their voice channels were preset and clear. German counterparts using AM would often be deafened by static, lose contact when command vehicles were destroyed, or struggle to re-establish signals when moving through gullies or over ridges. German armored doctrine at Kasserine had expected stronger performance in communications. Panzer divisions had Fu G5 transceivers, command vehicles with transceiver/receiver combos, AM voice/CW modes. Wireless communications German Army, Wikipedia. Static and interference, engine ignition, vehicle electrical systems, dust and even humidity in desert mornings added noise. AM voice channels are less robust against amplitude disturbances. Range drop-off while moving. Fields of movement, hills, ridges meant that voice signals drifted below intelligible threshold. Some messages lost. Repeated. Hierarchy vulnerability. German units relying on command tanks. If those were disabled, subordinate tanks lost functional two-way communications. Some smaller units had only receivers or were delayed in reporting. While sources don't always record precise radio channel data at Kasserine, several memoirs and reports capture what it felt like. Irving Bromberg, U.S. Sherman tanker, later recalled during Kasserine that language over intercom and external voice nets mattered. Gunner, loader, commander, driver needed to share information quickly. Under fire, this saved seconds. Some U.S. units were bewildered by German tactics that executed sudden flank attacks. Those U.S. tanks with clear voice comms could react more swiftly, though often hampered by slow logistical support or lack of experienced leadership. German intelligence regarding Allied communications during early stages is less clear. Records show U.S. forces were slow to adapt in Kasserine in many respects. Leadership errors from Major General Fredendall contributed significantly to defeats. After the losses at Kasserine, U.S. command recognized that communication could not be a weak link. Several key changes followed. Leadership shakeups. Fredendall relieved. Patton took more direct command of two corps. Chain of command enforced clearer radio protocols and voice nets. Tactical adjustments. Emphasis on communication among tank units. Artillery support. Combined arms. More training. More emphasis on keeping radio sets in good repair, spare parts, and retraining of crews on radio discipline, that is, being heard, being clear, minimizing unnecessary chatter. Equipment maintenance. Crews learned to protect antennas, cables. SCR-508 sets were better serviced. Dynamotors maintained. Spare crystal frequencies kept ready in case of damage or interference. Some German units also attempted to mitigate AM limitations. Use of Fu G6 observation sets with greater power. Signal discipline. Limiting radio traffic to reduce detection. Switching channels etc. But these were partial, often inconsistent, and many AM sets still suffered severe static under movement. In the desert, dust-choked lungs, armor radiated heat. But above all that, voice mattered. You could hear engines, crack of gunfire, the whip antennas clacking. Then over that, a voice, advance left, enemy Panzer right flank, retreat to cover. FM voice nets crystal stable, cut through that chaos. German crews, by comparison, heard hiss, pop, garbled commands. They could see formation confusion, but often could not respond in time. The sky above Kasserine was not bursting with shells yet. It was pulsing with static and voice, the invisible network that sometimes saved men. Small U.S. forces that were not isolated because their radios worked maintained better cohesion. For example, units able to reposition under fire, call for artillery support, or send scouts forward. While many Shermans were knocked out or abandoned, those that kept comms operating were less likely to be surprised, more likely to have flank protection, and more able to react. German commanders sometimes frustrated by not knowing where Shermans were moving. Reports suggest U.S. units could shuffle under cover of terrain, using prearranged crystal channels that German AM intercepts found harder to decode in real time because of static noise and distortion. Even with FMS SCR-508, U.S. units had command failures, leadership miscommunication, supply issues. Sometimes radios couldn't fix bad doctrine. Environmental factors: sandstorms, heat distortion, terrain shadows valleys, hills sometimes blocked line of sight for antennas, vehicle damage disabled communication, crew fatigue. Inexperienced operators sometimes misset or failed to maintain crystal channels. German adaptation: when possible, command tanks tried to use longer-range radio sets, using better frequency discipline, but with mixed effect. By mid-1943, after North Africa, U.S. armored units were better drilled in communicating with radio voice nets. Shermans built later had more standardized installations. Crews more confident. When the Allies invaded Sicily and later Normandy, the communication edge would play a larger, more consistent role, not just in isolated moments, but as a core element of Allied armored warfare. Kasserine taught a painful lesson. Technology can't compensate for everything, but when combined with doctrine, training, and leadership, it can shift the balance. As Americans prepared for Mediterranean invasions and the push into Europe, the radio nets would be among their greatest unseen weapons. After the deserts of North Africa revealed the strength and the limits of Sherman radio nets, the Allies moved into Europe. Sicily, Italy, then Normandy. Dense terrain, hedgerows, thick forests. It was here that the clarity of FM voice nets would be tested like never before. While German armor still gleamed with powerful guns and heavy armor, the Americans' toolbox now included something quieter, something invisible, but in many battles, utterly decisive: communication. Summer of 1943. Operation Husky, July 1943. The Allied invasion of Sicily put Sherman tanks into terrain full of ridges, rocky hills, orchards, and narrow roads. SCR-508 sets were already widespread among Sherman medium tanks. Crews carried spare crystals. Whip antennas were rigged carefully to maximize effective range. Fog and dust, olive groves, and mountains all conspired to break line of sight. Flags and flares could only do so much. But voice nets, preset channels, crystal control, and FM clarity allowed Shermans to coordinate advances even when one tank could not see its neighbors. In Italy, the advance northward forced artillery coordination, liaison with infantry, reacting to ambushes. When German Panzer or Sturmgeschütz units struck from hidden positions, U.S. Sherman commanders with good radio nets could direct supporting fire, call for reinforcements, or reposition with awareness of flanking threats. German command AM radios still functioned, but often with dropouts, static, sometimes no response when transmitting under movement or through foliage. June 6, 1944. Normandy landings. Sherman's rolling off landing craft through flooded fields with hedgerows hiding German defensive positions. From Omaha, Utah soared, gold beaches, the noise of landing craft, engine motors, men shouting, communication chaos. Sherman crews with SCR-508 systems used voice nets to coordinate not only among tanks, but between tank units and infantry, benched mortars, engineers opening gaps. Preset FM channels helped avoid confusion. Channel for tank company, another for infantry liaison, another for artillery support. It meant that Sherman unit commanders shouting across trenches became less necessary. Orders could be sent over voice by radio. German defenders, especially in hedgerow country, had visibility, but their radio clarity was uneven. Fu G5M voice sets, when used, often suffered static, especially among movement and interference. German command of terrain was high, but miscommunication was still common when command tanks were knocked out or when units were split. Veteran recollections are patchy when it comes to specific technical details like crystal sets or transmitter wattage, but many mention how vital voice was. Bill Betts, a British WWII tank veteran who served as a radio operator on Shermans, said after viewing the film Fury, "Very realistic, but it can't show the full horror of war." He trained as radio operator and fought alongside Americans, recalling how every clear signal meant survival. Clarence Smoyer, gunner in a Sherman with the U.S. 3rd Armored Division, recalled how being in a Sherman saved my life during the capture of Cologne. Smoyer and his crew had better communication, better reaction when targets appeared. We went through many battles with a tank like that, and it saved me. Though neither Betts nor Smoyer describe in public sources exactly which radio channels or specs they used in every battle, their testimony aligns with what technical sources say. Radio clarity and reliability saved lives and improved coordination under fire. German armored units in Europe had doctrine that assumed radio use. Command vehicles with Fuji 5 sets, some with receivers only, some transceivers. But several limitations emerged. Terrain. Hedgerows in Normandy, forested hills in France, mountains in Italy all cause signal attenuation. AM voice signals struggled when tanks moved through dense tree cover. Antennas often blocked by foliage or damaged. Command loss and limitations. When command or radio tanks were destroyed, subordinate tanks sometimes lost voice contact. This was more damaging for German units because many lower-tier tanks had other weaker receivers/transmitters or only receivers. Signal interference. AM sets more sensitive to electrical noise engines, ignition systems, weather static, and distortion under load. Reports by engineering and signal intelligence teams show that voice AM becomes unclear when moving or when overlap in radio traffic is high. Operation Cobra, July 1944, Normandy breakout. Sherman units had been building up momentum, cutting German defenses. During the breakout, rapid flank maneuvers, infantry/tank cooperation, artillery calls were frequent. Units with good radio nets had an advantage in exploiting gaps. German counterattacks often bogged down where coordination was weaker. The Falaise Pocket, August 1944. German retreat turned into rout. Shermans with radio coordination sighted blocking units while others pushed ahead, sealing escape routes. Communication allowed Allied armor to coordinate with air reconnaissance infantry and armored cavalry. German units, already suffering from fuel shortages and disrupted lines, found themselves trying to move retreat forces without reliable communications. Italian campaign. Monte Cassino and Gothic Line. In mountainous terrain, tunneled passes, ravines, clear voice comms were hard. But where Sherman's engineers, artillery, and infantry established voice net coordination, it made a difference. Calling in support, avoiding ambush, planning flank attacks. German defenders defended terrain strongly, but their comms were more brittle when units were isolated. From the Sherman tank site, a transcript from a U.S. Marine tank company during the Okinawa fight shows radio chatter's clarity and immediate decisions. This is Red 2, Red 1. Heartburn says that he is ready to start shooting at those pillboxes. Tell Heartburn I can't receive him. You will have to relay. Tell him to give us a signal and we'll spot for him. Heartburn, raise your fire, you're firing right into us. That's not Heartburn, Red 2. That's a high-velocity gun from our left rear. Red 1 out. This kind of instantaneous coordination, fire direction, warning, correction, is what SCR-508 voice nets enabled, and what many German AM-equipped units found hard to match under conditions with multiple moving elements and battlefield noise. Even FM and FM voice nets weren't perfect. Field conditions caused antenna damage. Whip antennas sometimes broke in transit or combat. Dynamotors needed maintenance. Spare crystals might be missing. Crews had to manage radio discipline, avoiding chatter, ensuring clear transmission, avoiding interference between channels. In thick hedgerow combat, confusion sometimes emerged even with good equipment. German countermeasures, occasionally using signal jamming though less developed, using quieter movement, alternate communications runners, visual signals, interleaving messages to avoid detection. Not always successful, but some German commanders attempted to limit interoperability of American voice nets by disrupting line of sight or radio elevation. Where once the sky over Kasserine crackled with voice and static, Normandy's sky echoed firm commands, corrections, orders over voice. Shermans could speak across fields. Tanks that could not carry heavy AM voice sets were left listening, often in confusion. The network of voices, hidden but strong, became as much part of warfare as armor or a gun. German field reports sometimes praised Allied coordination as unusually smooth. Intelligence assessments noted that American units often appeared to react faster than anticipated, artillery support arriving promptly, flank maneuvers converging with little visible signal beyond radio chatter. These observations unsettled German commanders used to controlling visual signals, dispatch riders, or slower AM channels. German signal intelligence SIGINT monitored American VHF/FM traffic when possible. However, FM modulation, crystal control, and clearer signals made interception harder in many cases. German reports sometimes mention hearing American voice nets that cut through noise, though exact technical detail is rare and often anecdotal. By late 1944, Sherman units, especially in Northwest Europe, had refined protocols, preserved crystal channels, redundant communication paths, inter-unit coordination across armor, infantry, artillery, and air. When the Battle of the Bulge began in December 1944, these voice nets would be mobilized fully, not just in offense, but in emergency defense, supply coordination, and counterattacks. The hedgerows fell, Germany's walls crept back under Allied armor. But the real conquest was often unseen. Voice carried over tangled fields and forests, with Normandy's beaches taken and breakout underway. The next decisive moments would test whether clear communication could compensate for German firepower and terrain advantage. Having seen how Sherman's radio shaped victory in North Africa, Sicily, and Normandy, American armored units entered the hardest crucible yet: winter in Europe. Dense forests, narrow roads, surprise attacks. The Battle of the Bulge and Market Garden would stress communications, expose weaknesses, and highlight just how much radio clarity could decide victory or defeat. December 16, 1944. Morning mist, snow, and German guns unleashed Operation Wacht am Rhein. The Germans expected confusion among Allied lines, but what they faced instead was a U.S. forces networked defense powered by voice nets, clear radio linkage, and rapid counter-coordinations. Sherman units equipped with SCR-508 series radios could call for supporting armor, resupply, artillery, even reinforcements across ridges and forested terrain. While heavy snowfall hampered movement, radio voice communication allowed U.S. commanders to reorganize defensive lines quickly, shifting tanks to plug gaps without relying entirely on visual signals. German units with Fu-G5 radios, often hampered by static or damage to antennas, found it difficult to mass regiments or move columns without exposing themselves. Loss of command tanks occasionally severed coordination. German doctrine expected armored formations to fight as coherent massed units, but without communication. Coherence faltered under Allied pressure. In September 1944, the ambitious Allied attempt to seize bridges in the Netherlands reached deep into enemy territory, and cut off German forces hinged on rapid movement and coordination. Sherman supporting airborne forces, infantry, motorized units all needed to keep comms tight. American units with SCR-508 voice nets relayed intelligence from scouts, coordinated tank-infantry link-ups, called in artillery, and responded to German counterattacks along multiple axes. German defenders, many less well-connected, sometimes could not respond to shifting Allied thrusts with precision. Command tanks that had more capable radios or less damaged sets fared better. Others were delayed. While direct quotes on radio tech in Bulge/Market Garden are rarer in public sources than technical manuals, there is some documented German awareness of Allied communication efficiency. German signal intelligence notes and prisoner interviews often contain observations of unusually coordinated Allied armor movements, which are attributed by historians to better command and communication systems, though not always named as FM or SCR-508. One German veteran in post-war memoirs said that sometimes they heard Allied tanks shifting positions, reacting, covering flanks, almost like they were speaking with each other. The implication being radio voice nets rather than visual signals or traditional coordination. Defense of Bastogne, December 1944. U.S. infantry and armor trapped. Sherman's with good radio nets kept supply convoys coordinated. Artillery support calls effective, even under siege. Clearing roads, rerouting reinforcements depended heavily on radio communication. Counterattacks during snowfall and surprise German push. When German columns broke through, U.S. commanders could direct overlapping fields of fire, mobile tank units, and flanking maneuvers. Clear voice communication meant less delay in reacting to German breakthroughs. Market gardens drop zones and bridge seizures. Paratroopers, infantry, Shermans all had to interlace movement according to schedule. Any lag could create gaps. Units with functioning SCR-508 sets held synchronized movement. Those without suffered delays, miscoordination, or mistiming. Command vehicle priority. Germans increasingly concentrated their best radios in command tanks, but this made those tanks prime targets. When command tanks were knocked out, subordinate units often fell into confusion. Radio discipline and frequency changes. German units sometimes tried to limit radio chatter to reduce detection, avoid interference, restrict usage. But given AM technology, interference from owned vehicles, static, and signal dropouts were hard to suppress. Terrain exploitation. Attempting night movements, use of terrain masking, avoiding open ground, using forests to protect from detection or view of antennas. But these steps reduced mobility and speed, which came at high cost. Bulge. The ability of U.S. armor to shift reserves rapidly, thanks to clear radio nets, helped contain German thrusts at key points like Elsenborn Ridge, Bastogne. Even when weather-grounded aircraft, voice nets allowed U.S. armor and infantry to coordinate resupply, counter battery fire, and isolated defense positions. Market garden. Some of the failures bridge holdups. Late reinforcements can be traced to overloaded or damaged voice nets. But the successes where bridges were seized, where airborne reinforcements linked up with armor, often involved units whose radio stayed intact, whose voice nets functioned under movement and stress. From the Sherman tank site, a post under the radios. The Sherman tank had some of the most advanced radios in the world at the time. Notes several crew memoirs praising clear communication in Bulge. Once our voice popped through the snow static, we realized we weren't alone out on the flank. German captured Shermans and interrogation reports sometimes commented that American tanks seemed to coordinate even in conditions where the Germans expected disorder, suggesting voice nets and preset channels. Even Shermans had failures. Broken antennas, damaged radios, low battery or dynamotor problems. Sometimes the FM voice nets would drop out in deep forest or thick wall of buildings in towns. German defenders sometimes used artillery to jam or suppress command positions. Weather and snow also interfered with line-of-sight antennas or canopy of forests. Equipment losses. When tanks destroyed, radio sets lost. Spare crystals may not be available. Replacements delayed. During Bulge, the sky was heavy with static, cold, flurries of snow and muffled explosions, but through that, cries of "tank here, support flank, retreat left," voice that carried across frozen ground. The motif shifts. Earlier silence broken. Now broken terrain plus winter plus voice. By the end of 1944, after Bulge and Market Garden, Sherman units had refined their protocols. Redundant voice net channels, backup receivers, crew training for radio failure scenarios. These adjustments often meant the difference between success and disaster in late war battles. The battles of Bulge and Market Garden proved the living power of voice communication. Not just radios, but doctrine, crew discipline, field maintenance, leadership under fire. As the Allies moved into Germany itself, those voice nets became lifelines. After Normandy and the winter storms of Bulge, the radio nets carried Shermans far. But no system is perfect. Clarity required cost. Failures were real, and the Germans did not sit silently. In these later battles, the edge of FM voice comms was still sharp and sometimes badly wounded. Now we explore where the communication advantage faltered, German attempts to counter it, and what sacrifices were made for clarity in combat. Even the best equipment suffers in war. Sherman crews reported whip antennas torn off by falling debris, turret hatches leaking sand and water, dynamotors overheating. Radio narrators in after-action reports mention that sometimes BC 604 transmitters failed to power properly, or crystal oscillators drifted when vibrations and temperature extremes took their toll. In winter 1944, as Shermans pressed through mud and snow into dense forests, antennas were frequently damaged, lowered for cover, or flattened by falling trees. Some Shermans were isolated not because of enemy fire, but because their radios simply failed. Engines cut, Voice net silent. Those moments often came just before enemy counterattacks. Crew training could only compensate so much. Younger tankers inexperienced with maintaining delicate radio gear sometimes miswired ground leads, allowed dust or grit into connectors, or misread which crystal channel to select, delays that could cost lives. The Wehrmacht, recognizing the American advantage, moved to adapt. These adaptations came in doctrine, in signal discipline, in tactics, though often too late or inconsistently. Prioritize command radios. German command tanks increasingly were given priority for best AM sets, sometimes extra layers of receivers/transceivers. But this placed them under additional risk. Command tanks often targeted by Allied armor and aircraft, and when destroyed, subordinate units lost much of their ability to communicate. Alternate communication channels. Runners, signal flags, dispatch riders, flares, these remained fallback for German units when radio failed. But these means were slower, vulnerable to enemy fire or terrain, and lacked flexibility. Signal discipline and channel switching. Some German units attempted to use quieter movement, delay transmissions, or switch frequencies to reduce detectability or interference. But AM systems have inherent limitations. Amplitude noise, static, interference, lower clarity under movement or in adverse terrain. Camouflage of antennas/terrain masking. Forests, hills, towns used to mask line of sight to reduce radio visibility. But antennas still needed to be exposed to some degree. Sometimes whip antennas stuck up and became shooting objectives. None of these fully neutralized the communication edge, but they showed that German commanders understood the circle. Better communication equaled better coordination equal battlefield success. While US had superior radio technology, using it effectively came at cost. Supply of crystal sets and spare parts. SCR-508 systems required spare crystals for preset channels. Damage or loss of crystals could reduce flexibility if spares were unavailable. Wartime supply lines sometimes delayed parts to frontline units. Training demands. Crews had to learn not just how to operate the radio, but how to manage channels, maintain equipment, select proper preset frequency, avoid interference, keep dynamotors clean, ensure internal intercom function so crew could relay info. These training and maintenance demands increased workload, visibility, and risk. Tanks using radio nets often needed whip antennas exposed, sometimes on turret tops or hulls, which could make them visible to enemy observers. Radio transmissions themselves might be intercepted or direction found, though the FM modulation and crystal channels helped somewhat. Dependence. When voice nets failed, units accustomed to them found themselves less nimble. If one command tank was destroyed, lower units sometimes miscoordinated because other redundancies runners, visual signals were insufficient. In Bastogne, snow and ice sometimes broke radio circuits. Shermans trying to coordinate relief convoys or supply routes sometimes had to delay because radio messages did not go through. Alternate communication messengers risked ambush or delay. Market Garden, September 1944. Some Allied failures, especially in timely reinforcing or rerouting, have been attributed to disrupted communications. When bridges held longer than expected, or when German defenders counterattacked, some Allied Sherman and infantry movement was delayed while awaiting orders, because voice nets were overloaded, channels congested, or radio sets in damaged condition. Italian mountains. In rocky terrain, small ravines and cliffs could block or reflect signals. Crews sometimes found voice communication fading when moving in narrow passes, or from lower ground to higher ground with obstructed line of sight. While direct quotes about FM superiority in late battles are still rare, German after-action and intelligence reports show recurring themes. Reports of American armor appearing more coordinated than expected, moving in support of each other, appearing quickly where needed, closing flanks. German commanders often listed communication or timing among factors in Allied successes. Signal intelligence agents sometimes monitored American voice nets. They noted clarity of voice versus what they heard from some German AM nets, crackling, delays, static under movement. Though these reports seldom name the technical basis FM versus AM, historians infer these observations align with known features of SCR-508 sets, e.g., Writings in German military journals post-war about voice delays, chatter being heard over noise. Tankers who depended on voice nets sometimes felt guilt or loss when communication failed. Survivor memoirs include stories of being in tank blind after radio damage, not knowing where the rest of the unit was, being surprised by enemy flanks or ambushes. Medics and commanders recall that bodies or wounded were found where tanks had been cut off because unable to receive orders to withdraw or reposition. Radio silence sometimes meant no help. Clear voice also exposed vulnerability. When one spoke over the radio, voice nets could be heard, intercepted, or locate targeted. Some commanders argued for bursts rather than constant chatter. Careful message discipline, but that sometimes slowed operations. Historians agree that Allied casualties were reduced in many battles where Shermans operated in well-maintained voice nets. Hard numbers attributing X% fewer killed because of better communication are rare, but casualty comparison studies between U.S. armored units versus German armored units in similar situations often list communication as a factor in after-action reports. Some German losses in coordination and exposure moving in weak light over open ground without flank cover are traced to poor or failed radio communication. These losses, while hard to measure in pure numbers, show in maps. When units lost contact, they faltered, retreated, or were enveloped. According to articles in World Politics and other military history journals, battlefield communication is now seen as often equally decisive to armor or firepower. Historians assessing WWI cavalry armor, ETSI, say that voice net clarity and speed of command transmission made superior equipment count more. German radio intelligence reports declassified show concern about Allied radio discipline and clarity. One such report, Albert Prahn's German radio intelligence, points to difficulties intercepting Allied transmissions because of frequency stability and use of preset crystal channels. Declassified documents at NSA show these reports. Radios, spare crystals, dynamotors, antennas all cost dollars, weight, logistical effort. Maintaining frontline units with functioning communication gear required supply priority. Doctrine had to catch up. Once the failures at Kasserine and in some parts of Italy showed that mere hardware wasn't enough, U.S. forces formalized procedures, signal maintenance, backup methods, redundancy channels, training for radio failure scenarios. Also, cost in men's lives when communication failed. When orders didn't reach some units, when flanks couldn't be warned, casualties rose. Earlier battles were about static, interference, the fear of, "Can you hear me?" The sky was loud with noise. But by late 1944, those breaks of clarity, when voice broke through static, felt like a small victory. In those moments, in snow, mud, under fire, communication lit the battlefield like lightning. The price was high, equipment lost, voices silenced, men cut off. But the reward often meant survival or victory, with costs tallied, failures witnessed, and German countermeasures understood. The stage is set for the legacy. What remained after war's end? How these voice nets shaped Cold War doctrine, modern communications, networked combat. When the last snow melted over the Ardennes and the guns silenced in Europe, the voice nets built by Sherman crews did not vanish. They evolved. Post-war tank doctrines, modern armored communications, even today's networked battlefields carry echoes of SCR-508's crystal channels, of FM clarity, and of the cost paid for voices that once cut through smoke and static. The SCR-508 series didn't disappear with VE Day. It remained in U.S. service into the Korean War era. Many mid-war Shermans and successor U.S. armored vehicles continued using these radio systems or their derivatives. The fact that the SCR-508 was designed for both FM voice and intercom communication among tank crew stations was forward-looking. The turret bustle of late-series Shermans and many armored vehicles was laid out to accommodate the microphone, intercom boxes, receivers, and whip antennas. These physical designs, carrying echoes of doctrine, carried into Cold War armored vehicles. After WWII, U.S. Army armored and infantry schools studied the lessons of coordination and communications. Post-war doctrine gradually emphasized combined arms operations relying on voice nets, redundancy in command communications, inter-vehicle command and control. Communication networks were considered force multipliers. A platoon or battalion that could talk reliably could move faster, respond quicker, exploit opportunities, and reduce friendly fire. University theses and military doctrine studies, for example, U.S. Army communications in Europe, 1942 to 45, show that by the end of the war, commanders were able to communicate continuously with support elements across distances previously unthinkable under chaotic battle conditions. Over time, as vacuum tube radios like SCR-508 gave way to transistor or solid-state radios, many of the same design principles held. Preset channels, FM voice, stable frequency control, intercoms, redundancy. Modern armored radio suites borrow from FM clarity, low noise, inter-crew communications, multiple channels, backup equipment. The need to ensure that commanders, gun crews, drivers, support vehicles can all talk, and often at multiple power levels, became standard in military procurement. Allied nations, British post-war radios adopted similar voice net models. VHF FM sets became more common. Even the British wireless set number 19, originally an AM/CW radio, saw later versions and replacements favoring FM and VHF for intra-armored communications. Other nations' armored forces integrated similar technologies. Better power, inter-vehicle networks, built-in intercoms, options to monitor multiple channels, and later, frequency hopping at sea. Today's tank battle networks are complex. They include digital radios, encryption, frequency hopping, satellite links, data links, inter-unit video feeds. But many of their roots are in FM voice, nets like SCR-508. For example, modern US and NATO doctrine insist on command and control C2 radio communication, with redundancy, situational awareness, real-time voice, and sometimes text/data. Channels are preset. Voice clarity under engine noise is tested. Antennas in systems designed for harsh vibration, shock, temperature. FM voice remains preferred for its clarity under movement, lower noise interference compared to older AM designs. When modern armored units talk about net discipline or secure voice channels, those ideas derive in part from lessons learned with SCR-508 and comparable WWII systems. A post-war SCR-508 technical manual notes that many crews reported that voice clarity muted static. Preset channel switching made real differences in intense combat, especially as terrain and weather worsened. German intelligence memoirs declassified include Albert Prahn's German Radio Intelligence, which remarks that Allied communication discipline and radio stability made Allied armor more nimble and more predictable in offensive pushes, even in areas where German lines expected to control the terrain. Even as technology advanced, there were inherent risks: enemy interception and direction finding. Radio transmissions could be intercepted. FM helped somewhat with clarity, but voice nets still risked giving away unit positions. Direction finding DF teams could locate transmitting tanks. This forced radio discipline: when to talk, when to keep silent. Equipment theft or capture. As war progressed and territories changed hands, sometimes radio sets were destroyed to avoid capture. The loss of radios meant significant disruption for units that had come to rely on them. Training burdens. Modern armies still drill heavily in communications, multiple alternates, backup radios, and ensuring redundancy. The legacy of WWII radio failures informs current standards. In modern warfare, it's not just tanks, drones, digital comms, encrypted networks, real-time situational awareness battle maps, GPS, digital overlays. But even these sophisticated systems echo SCR-508's basic leap: reliable voice nets under movement, clarity under chaos, multiple channels for different parts of the force. Tactical radio systems like Singers for US or equivalent for NATO use VHF FM with secure channels, preset frequency slots, redundancy, and durability. These are direct descendants of the technology and doctrine begun with SCR-508 in WWII. While power levels, encryption, digital data rates have advanced, the basic features, crystal-controlled channels, FM voice, backup receivers, remain essential. Sin Seagar's background via military comms history. Though exact usage varies, The sky over North Africa once echoed with the first FM voice nets. Normandy's sky carried voice through bocage. Bulge's sky crackled with commands under snow. Today, that sky is layered, radio, digital, satellite, encrypted. But beneath all that, the voice nets born in WWI still persist. Every modern armored advance still relies on lines of voice, chains of command, clarity under fire. When people talk about best armor or biggest gun, they sometimes underrate what made U.S. Sherman survive. Not just steel, not just speed, not just numbers, but clarity, the ability to talk, to hear, to coordinate in real time. That advantage allowed Shermans to be greater than the sum of their parts. German tanks, Panthers, Tigers were formidable in many respects. But even they could not always compensate for weaker comms in bad terrain. When command tanks were lost, when AM noise overwhelmed voice. The legacy of this reflects in how modern warfare sees platforms as parts of networks. Always speaking, always listening. The story of Shermans and their radios is one often unseen. The guns, the tracks, the tanks get the glory. But behind that, there was voice, crystal clear, FM voice across muddy fields, over dunes, through winter cold. It was that voice which connected units, which let officers lead not just by sight but by sound. It was that voice which, more than armor or gun, carried Allied success from Normandy through the Rhine. The sky that once betrayed in snow now remembers the signals, the static broken, the voices that became doctrine. And in every modern tank net, in every armored push, one hears echoes of radios like the SCR-508, speaking truth into war.